Hi, good evening, students. Today's topic is IoT for fog computing. Okay, hope you can see this document. So, IoT and IoE applications on fog infrastructure. So, this is a schematic diagram. So, schematic infrastructure. So, here you can find application A and application B. Okay, so application A, this is for application A cloud, and this is application B cloud. So the next is multi-services edges. So consist of fog layer. So fog layer, two applications in A for fog and one application for B side. So that comprises the fog, and one core stage is available for B, and here no core stages are available for application A. So the third one is sensors and embedded systems. So endpoint application for A, and this is endpoint application of B. So each layer consists of application, OS and VM layers. Okay. So two application and one databases for both the cloud applications. Okay. So this is a data center cloud, and the next one is multi-services, so such as 3G, 4G. Now it is for 5G also. How you are going to connect for the Ethernet or PLCs, some programs. Okay. And the third and the final layer is embedded systems and sensors. Okay, so this can be either of wired or wireless layer. Okay, so this is the infrastructure for IoT as well as IoA applications. So the cloud computing consists of mostly homogeneous physical resources, so that are deployed and managed in a centralized fashion. So fog can extend to the cloud and as well as to the edge and finally to the endpoints. Okay? So these are the comprises of fog complements. Okay? The fog distributed infrastructure comprises of heterogeneous resources. So the previous one is homogeneous, the second one is heterogeneous resources. So that needs to be managed in a distributed fashion. Okay? So that can be identified in figure 3. Now the fog architecture enables the distributed deployment of application requiring computing, the first one. Next one is storing. The next and the final is network resources across the different players. Okay. Similar to the cloud, fog also supports coexistence of applications belonging to different tenants. So each tenant perceives its resources as dedicated and define its own topology. So the next figure shows two tenants, so that is A and B. So here respectively the applications. The distributed application for A so has one cloud component and two fog components, as we discussed in the infrastructure diagram. Similarly, the application B has one cloud component and a fog component and a core component, so that is not available for application A. So here a virtual network topology is allocated for each and every tenant. So in order to fulfill the manifest, first it is in distributed architecture. The fog relies on technology components for scalable virtualization of the key resource. So the key resources comprises computing, storing, and networking. Computing requires the selection of hypervisors in order to virtualize both the computing and I/O resources. The next one is storage. You have to store the required virtual file system, both computing and input-output resources. Finally, the storage of your virtual file system and a virtual block and or an object store. Okay. Networking requires the appropriate network virtualization. For example, it is depends upon the software. So, which software define the network topology? It is similar to the cloud. Okay. Fog leverages a policy-based orchestration and provisioning mechanisms on top of the resource, a virtualization layer for scalable and automatic resource management. Finally, this architecture exposes APIs for application development and deployment. Okay. So the next will be how you're going to estimate the cloud and IoT. So basically it depends upon the state estimation for the physical devices. Then virtual objects, so you can estimate your cloud and fog using VO. Okay? It is like virtual objects. And finally, the micro engines. Okay? Micro engines in terms of phasor voltage at each node and branch current phasor for each branch. So these are the three types or three techniques used for estimating your cloud and fog. Okay? Finally, the benefits and comparison of IoT and cloud that you can be. I will be sending this doc. You can refer to this how cloud and IoT differs based upon its characteristics and storage capabilities as well as processing speed and capabilities, how to connect, connectivity, how to store the data, either big data analysis or how to manage the data, and the benefits of fog computing are listed below. Okay, so thank you one and all for listening. And foremost is, if you have any doubt, you can discuss in the discussion forum. You can contact through WhatsApp or in Moodle classroom. You can chat in the discussion chat available in the Moodle classroom. Okay, thank you one and all.